Hello everyone, and thank you all for being here. We know that there are a lot of good sessions out there to attend, and we would like to especially thank you for being here with us today. So our session today is a flight plan for data security, more specifically safeguarding your data set with dynamic object level security. First, just a quick introduction on who we are. My name is Diogo Martins. I'm a BI specialist at DevScope. If you don't already know, DevScope is a Microsoft Solutions partner that is based in Porto, Portugal. And I have here with me my colleague José Calheiros, who is also a BI specialist at DevScope. So just a quick overview on our agenda. So we'll give you a brief introduction and explain a little bit about the project that led to the development of this solution to give you a bit of context. We'll get a bit into object level security. Then we're going to show you how to use PowerShell to modify Model Beam. This will be the focus of our session. We're going to show you how you can use PowerShell to manipulate a Model Beam. In this specific case, more oriented to object level security, but you can do many things with PowerShell to modify the Model Beam. And then we're going to get into the use cases. In this case, first, we're going to take a look at dynamic object level security from table metadata, then dynamic schema update from database schema, and finally, we'll add those two examples together. So, me and Jose worked on a project a couple months ago, and basically our client had an end-user application. In this specific case, it had human resources data, and basically everything from jobs, candidates, submissions, timesheets, and so on. And he basically wanted a self-service reporting tool for their end users based on the data from this application. Now, the catch here is that there are customizable fields and permissions. And what do we mean by this? For example, let's say I'm a company and I'm using the app and I want to post a new job. However, the native fields from the app are not enough for what I want to post, so I create a new field. So every end user, or almost every end user, has the ability in this application to create new fields of their liking. And with that comes the permissions for those fields. So only the users for that specific tenant can see that new field, and even some specific users within the tenant. So we have to keep attention to these permissions and be very careful. On top of that, we also add real-time data, and of course as well, all the permissions and schema updates. Now, as you might have already noticed, we are facing here an object level security issue because we have custom permissions that are that the user defines by himself. So very briefly, object level security basically enables you to add objects to specific report viewers, and by objects we understand for tables and columns. And now there's a big difference that we have to see here, that between, in this case, row level security and object level security. Row level security can be dynamic. With a simple DEX expression, you can return different sets of rows for different report viewers, right? On the other hand, with object level security, you don't have that ability. First, you have to use Tabular Editor, an external tool, to configure object level security, and you do not have the same ability as with row level security, where you still write a simple expression and you return different objects depending on that expression. So now I'm going to show you how you would normally set up object level security with Tabular Editor. So let me show you here. So here we are using Tabular Editor, that is an external tool. This external tool basically accesses all the metadata from the data set, okay? Basically this file is a Model Beam file, and this file basically contains all the metadata from the data set. It's the only thing it contains, okay? And we are using Tabular Editor to access that metadata. If you're not already familiar, this interface is very simple. We have here a couple of folders with the objects. In this case, everything from data sources, relationships, and so on. But we're going to focus here mainly on the roles and tables folder. So to configure object level security, the first thing you need to do is create a role. So that's what we're going to do. We're going to create a new role. In this case, let's call it role 1. And now let's say that we don't want role 1 to see the customer name column from the sales details table. So we have to navigate to that table, the sales details table over here, and look for the customer name column. So here it is, customer name. And if you scroll here on your right side, you will see at the bottom the option object level security. So if we open the drop-down, we can see role 1, and it has this value, the default value. So by default, every role that you create will have access to every object in the model. And in this case, role 1 has access to this object, and we want to remove access to this specific object, so we'll choose none instead. Okay, so here we are, and if we now go back to the role, we can see the sales details table specified over here, and again, on your right side, you'll have the object level security column permissions, and you can see that in every column for this table, the only thing he does not have access to is the customer name. And you would do this with every object you would like to hide for this specific role. And this is basically a normal setup with object level security. So let's get back now. One thing I'd like to mention, as you noticed, what we are doing is basically removing access from specific objects, because by default, everyone has access to everything. And this is an important note, because this will be important further ahead when we are using our PowerShell script to manipulate. So just keep in mind, we remove access from specific objects, okay? Now let's go back to our presentation. Okay, so now just a quick overview on the security architecture we implemented in this project. So as you can see, we used Jenkins in this specific case. So we have a pipeline in Jenkins with several triggers, and when this pipeline ran, it would run our PowerShell script. Basically, what would happen was it would get the BIM model. In this case, it was stored in Bitbucket, and we would also query a lakehouse to get all information regarding column permissions and also schema updates. After running the PowerShell script, the BIM model file, the new manipulated BIM model file would then be pushed back to Bitbucket. We would publish the new BIM model to Power BI service, and then that same semantic model would then be connected to several reports in Power BI service.
Okay, so now going to a more technical part, we are going to see how we can use PowerShell to modify a model BIM. So basically, as Diogo said, this accesses all the model's metadata, and we're going to run a simple example where we are going to, with PowerShell, connect to a model BIM file. We're going to access a specific column and change its name. So a pretty simple example, so you can see how you can change things around in Power BI with PowerShell. So we have here our first PowerShell script demo. And mainly what we are going to be doing, just give me 1 second here. Let me just get the windows done. Okay. So mainly what we are going to be doing is that we have a sales table that has a bunch of columns, and we are modifying this column name. This is just an example, okay? So the script basically defines some variables, in this example, the model path. And then we are just defining the current path for the script. Then we are getting the content from the actual model BIM file. Okay, so we are creating this PowerShell object to modify it. And then we are accessing the first property, or the first object, which is the tables object that contains all the tables in the model. And we are filtering for the sales table. Okay. Then we are accessing to this columns property, which has the columns for the actual table. And we are accessing the total price column, which is this one. And then we are just changing its name and writing the output to the BIM file again. Okay, pretty simple example. So if we run this, okay, so it was pretty quick. So I'll just close this window. Okay, sorry, should you want to quit? I'm sure. And if I open the model BIM again, we can see that the column name has been changed, okay? So this is just a simple example to show you that with PowerShell, you can just manipulate basically all the metadata that is in the model, okay? So now this is fun, of course, but we want to be able to modify, and in our specific case, and it could be helpful for you guys as well, we want to be able to modify Power BI datasets, right? So here we are presenting we are not presenting, we are using an API, a Microsoft Fabric API. It's a new API that works at the Fabric item level. So basically, what is a Fabric item? It can be a data set, it can be a report, a Python notebook, a lakehouse. It's in the Fabric environment. And it's a CRUD API, so we can insert, we can delete, we can update. It has a lot of possibilities. And to facilitate the connection and to facilitate the use of the Power BI Fabric API, we are using this Fabric PS PBIP module. To use this module, this is a Microsoft module, okay, it's maintained by them. So you just need to use PowerShell 7, and it just facilitates working with API. It has some useful endpoints, like you can authenticate yourself really easily. You can extract the items from Power BI service really easily and import the items as well. Basically, before we go into the demo, we're just going to show you the architecture that we are going to use in this demo. We have this PowerShell script, as we've shown you, that it's going to connect to an Azure SQL database that is going to contain some metadata, because now the examples that we are about to show you are basically modifying the model beam or the Power BI dataset with some Azure SQL metadata, okay? So the PowerShell script is going to be managing this, is going to connect to Azure SQL and do some transformations to the beam model. And then we're going to have the Fabric API just exporting the semantic model to a local or a cloud server, and then do the transformations and importing it again to Power BI service, okay? So that's what we are going to do. We need PowerShell 7, as I've said, and we're going to do this. By the way, you need to install the Azure PowerShell module, but if you check the model documentation, you have all the steps where you can configure, where you can download the files, and just set it up for you. We're going to authenticate to our tenant. We are going to import a model, do some transformations, and exporting it again. So, for this, we have another, I don't know if you, yeah, let me just grab some more windows. So for this, we have another script. Here we are just defining some variables like workspace ID, dataset ID, and so on. And we are importing the actual module that I've taught you about. And we are going to use a config file with some information just for us to authenticate ourselves. We have here an example. We have like the server name for the Azure connection database, the user, the password, the server principal secrets. Here's just an example, and we don't, maybe this is not the best practice to have your credentials exposed in a fact file. You could have more secure approaches like having this on Azure Key Vault, for example. But this, for this presentation, it's enough to show you what we want to show. So let's go then to the example again. So we use the config file to get our secrets and our variables and so on. And then the first step is to authenticate ourselves to Fabric. So what we need to give as an input is basically the service principal ID, the service principal secret, because we are authenticating with a service principal. You can also authenticate yourself with a user, okay, if it has the proper access. But in this case, we are using a service principal. And you just need to give the tenant ID. Then we are defining an export path because we are getting an item from the actual workspace, and we need to say, okay, we want to sync the result in a specific path. We are exporting this item, so we are giving, again, the path. We are saying that the item is in the specific workspace ID, and we are filtering the item by ID. In this case, it's a data set, so we are downloading it to a local machine. Then it's the same thing. We just need to get the content, because now we have it locally. We need to get the content and create the PowerShell object, and we are doing the same exercise. So we are finding the sales table, finding the total price column, and renaming it to total. Then writing the output again to the BIM file, and then importing it again to Power BI, okay? So we're going to show you real quick how the data set looks like. So as you can see, we have here a sales table with a total price column. And now, when we run this script, so it's authenticating itself, as you might see. It found one item. Now we'll be downloading this item. We'll have some transformations to the model beam, and we'll be importing it again. It's just taking a little bit. OK, it's done. Let's refresh the page. So again, we are on the same data set, and you can see that now the column changed its name. So it's that simple to just automate the process like this with Fabric APIs and modify metadata from your datasets. Now Diogo is going to show you a better example, or a prettier example.
Yeah, so right now in this demo we're going to show you the dynamic object level security from table metadata. Just some quick notes. Of course, here we're going to query those permissions metadata from our Azure SQL database. Then, of course, you're going to use PowerShell to manipulate object level security configurations in that model beam file. And finally, as Jose showed you right now, we're going to deploy the manipulated tabular object model to Fabric. So you can here take a quick look on the queries you're going to make, but I want you to focus here on this hierarchy here on the right. So the main objects we are going to manipulate here on this PowerShell script will be the roles, one that you see at the top, right? And then we also have the table permissions, and within those table permissions, column permissions, that's where we're going to set the object level security configurations. So those will be the three main objects we're going to manipulate with the PowerShell script I'm going to show you. So let's head over to our PowerShell script. Sorry. OK, so our next script is over here. And OK. Just get this here, and we're done. So on this script, the initial part is pretty similar. Sorry, so it's pretty similar to what Jose already showed you. We have a couple of parameters over here, and we also have some custom functions we built, but we won't get into much detail in those because, as I showed you in the beginning, we have a link tree with also our GitHub rep where you can check our PowerShell scripts in more detail. So let's move along. Here, again, pretty similar to what Jose already showed you. We have the current path, modules. We get everything we need from the config file. In this case, we're also getting the Azure database authentication credentials. Here, we also get the select statement. So we have some SQL queries stored here on the folder, and we are getting the select statement itself, so we can run that select statement against the Azure SQL database. Again, we export everything we need. In this case, we only export dataset, as Jose already explained to you, and then we get its content and start working on our PowerShell, on our model beam file. So the first thing we need to do here is to check if the roles object does exist in the model beam file. As you can see here on the left side, we do have the roles folder, yeah, but however, it's empty. And when the folder is empty, the object itself is not created in the plain text file. So we have to create. But nevertheless, what we're doing here is checking if it exists. Well, if it does exist, we don't do nothing, of course. And in case it doesn't, that's the case here, we're going to add this new object to the model, OK? And that's what we're going to do in this first step. After creating the roles object, we're going to add the roles to that object here. So on the next step, we have this variable, the DB roles, where we are using our custom function, the query Azure database, and we are doing the query roles query. So if you take a look here on this, here on the bottom left corner, you can see that we have this query over here, and we're basically, it's a very simple query. As you can see, we're simply getting the names of the roles we want to create in this model beam file. Okay, so after getting the results from this query, we're basically iterating each one of these roles. And when iterating, we're going to check, OK, does this role exist in the model beam file? And if it doesn't, we're going to create, in this case, a PowerShell object for it. So the structure of the object it basically has the name, right, annotations, model permissions, and table permissions. So here just some quick notes. Here regarding the annotations, we did a couple of tests, and we were not able to have this properly working without the specific object, especially in Power BI service, where we had some issues. So the way we found to have this properly working was to keep the annotations object with in this case, PBI ID, and basically an alphanumeric string with 32 characters as the value. Again, here we are using also a custom function we built. This is basically generating that string with the role name, so it generates a custom string for each role name that there is. So this is that, and then at the end, of course, we're going to add that role to the roles object, and this is what we do in our first steps. So let's see this in action, so we can grasp a little bit better what we're talking about here. So let me just close the file, and let's run this first section of the script. Here's going basically creating that roles object that does not exist in our file, and we're going to add all the roles that in this case will be sales, procurement, and intern. It's doing all the operation it needs, and it's done. So let me just open the model beam file. Now the updated version. In this case, we are only writing it locally. We're not importing it back to Fabric, okay? So let me just go here, and we can take a look at it. So as you can see right now, we do have some objects in the roles folder, and we have all of the objects here regarding for each role, sorry. So here we have sales, procurement, and intern. So again, we created the roles object, and we added these roles to the roles object. Now, the only thing left to do here is to add the permissions for each object. So let's just, we don't need this no more. And now we're going to add the permissions. So again, we're going to query our Azure SQL database. We're going, in this case, we're going to use the query permissions. And let me show you what this query is about. So I have it here. Also a very simple query, nothing special. And basically the result of this query returns us the permissions we want to implement here on this data set. So as you can see, on the left side we have the role name, then we have table, column, and column permissions. So in this query, what you're getting is basically the permissions for each role and for each specific object. As I said before, we are removing access to specific objects. So as you can see right now, we only have zeros in the column permission because we are removing access from them, right? But let's say, for example, we have run this script, and let's say, for example, the first line, the procurement role no longer has access to the customer segment column, but you want to give back access to that specific column. Very simple. You just need to change the 0 to 1, run the script back again, and the role will have again the access to this specific object, that in this case, customer segment. So after having the content from this query, we're basically going to iterate through each record of this query. So we're going to get role name, table, and column. That's the most important stuff here. And we're going to check the column permission. Okay, of course, if it's 1, it will be read. Otherwise, it will be none. Very simple. And then we're going to select the specific role we are working on. We're going to search for it in the model beam file. And then we're going to search for the table. Again, we are looking if this table exists within those permissions. In case it does not exist, we are going to add that table to the table permissions object from the role. So in this case, as you can see, any of the roles does not have any table, so they do not exist at the moment. So that's what we are checking right now. We're checking, okay, does this, for example, procurement role contain any table in the table permissions? Well, it does not, so we have to add that specific object. And this is basically this part, what we're doing here. So let me just also run this section, this first section where I showed you. And now let's just close this, and we can run this. So now basically we're only going to add the tables to each role. In this specific case, it will be the sales details table to the procurement and intern role. Again, it's running everything back again, and in a couple of seconds we will get the the new model beam file. Taking a bit longer than usual.
I think he's on the shy side today.
Yeah, today. When there's live demos, they're always shy.
Yeah, exactly.
So we're done. So we can open the model beam file. And let's just get back to our setup here. Sorry. Okay, perfect. So right now here on our left side, on our upper left corner, we can see the roles. And as you can see now, we have the sales details table over here in the procurement and intern role. So now the final thing we need to do is to add the column permissions to each one of these tables in each one of these roles. So let's do just that. Now we just need to uncomment this section, and I'll just explain you quickly how does this happen. And here basically we're going to check for the column again. If the column does not, we're going to check if the column does exist in this object. As of right now, we have added this object, right? That has, it's basically empty. It does not have any column permissions, right? And we're going to add those new columns. So here we check. If it does not exist, we're going to create an object and add it. In this case, it's very simple, just the name of the column and the metadata permission. In this case, it will be read or none, correct? And then we're just going to add that new column permission. If, of course, the column already existed, we would simply change the column permission, and we would just overwrite the existing column permission to read or to none or vice versa. So, and this is basically it. Now we can run the entire script, and finally we're going to import these to Fabric. So, in this case, Power BI service. So let me just show you what we have over here. Let me open the workspace. So as of right now, we have the security here. On this part, we don't have nothing, okay? We don't have any roles created as of right now. And we also have here a report to demonstrate this effect of object level security. We just have some tables here with columns from the sales details table that we're going to see what happens when we have a user accessing it that does not have access to them. So let's just go back to our script, and let's run this from end to end. Okay, running everything again. Let's see if it takes as long as it took the last time. We hope not. Okay, getting semantic model. Let me just close this as well. Okay, it's done. Let's just also take a look at the local file. Okay, so let's open the model beam file. And now, if we open the roles folder, now we take a look at the procurement. Let's just look at the procurement role, sales details. And as you can see over here, we have the object level security column permissions, and we can see 3 out of 11 columns that has object level security enabled. And as you can see, customer name, customer segment, and feedback rating have none. So this role basically won't have access to these 3 columns as specified on the metadata on an Azure SQL database. So let's just now take a look at the result in Power BI service. So let me just refresh the page. Okay, so now, if we go to the security section here of the data set, we'll see the roles we have created, okay? And right now we're going to test the procurement role. So we're going to test as role. And as you can see, the role cannot see those visuals because it does not have access to those objects. Of course, this is not the outcome we want. We don't want the viewer to see a report with errors, correct? We're just showing you this way for us to be easier and with the time we have. But the ideal would be, for example, let's say you have a user and you want him, when he builds the report, you don't want him to have access to the objects we have hidden from him. So what you do, basically, You just need to have the user as viewer in the workspace, and then you have to give them build permissions to the dataset. With that, when he creates a report from the dataset, because he has build permissions, although he's a viewer with build permissions, it will be able to create a report. He won't see those columns. In this case, the procurement role won't see the customer name, customer segment, and feedback rating when creating a new report. And now we're going to get back to our presentation, and Jose is going to talk a little bit more about it.
This is just another example. This is just another example that we had to do in our specific customer, but it's just another one that you can see that you can use for yourself if you have a problem that's related to this. So in the application that we've talked about, users are able to, it was not our application, it was a customer application. Users were able to create new fields, right? So they were able to create new fields in specific tables. And we needed to synchronize the schemas from the actual database from the client with Power BI database. So we needed to perform some dynamic schema update, okay? So this is the example that we are going to show you. Basically, what we are going to do is that we are going to query our database schema. We are just using this information schema.columns table. And we are going to iterate through the tabular model columns, and we are going to see if they exist or not in the source schema, so we can sync them. We are going to insert and delete these columns. So let's go over here to the demo. Just going to show you the 3 windows again. Okay. And is this one? It is. Cool.
It's that one.
Okay, so basically it's just, it's really similar to what Diogo have shown you. We get the config file, we authenticate ourselves to Fabric and Azure, we export the items, get the model beam, same thing. We do a database query, and in our case, it's a little bit different. We are checking for the schema. I'm just going to filter out the table that we want already. We are checking the actual schema in the database for a specific table, which will be sales details. And then we are getting the content from this specific query. And we are accessing the table's property from the model object. And we are filtering the tables that have an annotation with the name source table. So we have done this basically so that we can identify the tables that we want to perform this dynamic schema operation. Okay? So basically, this is a standard annotation. It's right here, so it has a source table name and the value sales details. We're going to use this value later on. So basically, we filter it, then we are going to iterate through the tables that have this annotation. In this case, it will be just one, but this is a generic script. So then we are getting the value for the actual source table annotation, because this sales detail is going to be filtering the query for the schema database. And then we are going to check the fields that we are going to be adding to the actual model. So basically, we are getting these fields, which are the schema from the source table. And we are iterating through these fields. And we are checking if these fields are on the model beam. So basically, we are checking if the database schema is the same as the Power BI schema. And if there is some field that is missing on the Power BI, we want to add this field, right? So we are just going to quickly add a field here. We're going to add our test column. And now, as you can see, the query has an extra column right here, which is the test column that does not exist in the Power BI model, right? So if the field does not exist, we are creating this object that has some properties. That is a column object. It has a name, which will be, and the value will be the column name. We have a data type string. So this this is probably not the best practices because not all the columns are strings. But if you want to take this to another level, you can have like a mapping with the data types from the source database to the data types on Power BI, do this mapping, and insert here a proper data type. But this is enough for this presentation. And again, we say that the source column has the same name, and we need to give this property as well, which is summarized by, and it's a Power BI property, but we don't want this field to be summarized, so we say none. And then we add this new column to the model. Then we'll need to do the other way around, right? Because we want to synchronize both schemas. So we are checking if the actual fields in the Power BI schema are in the database, and if they are not, we want to remove them, right? So this way, we get them synced up. And then, again, we are writing the output to a BIM file and importing it again to Fabric. So real quickly, let me just show you that we don't have here any test column. Yes, we don't. And by just running this, we'll be having the new column. So it's getting the model beam. Again, it's telling us to wait a little bit. It's sleeping. Okay, it has some parts. It's downloading the parts, writing the output, updating the item definition to the Power BI service. Okay, and we're done. So if we refresh these pages again, you will see that now we have a new test column here, okay? So although we have the column, this is just metadata, okay? It doesn't contain data yet. So in order to contain data, we need to refresh the model, and we need to have a proper query that gets this data from the new data from the fields. In this case, we have a partition in Power BI, which is mcode or Power Query, as you prefer, where we do a select star from the actual table. So as possibly some of you might know who work in Power BI development, select star, it's not really the best practice because it can jeopardize the schema of your model. But in this case, as we have dynamic columns, so there are columns that are going in and columns that are going out, we need to have the select star to get all the columns from the actual database. So if we refresh the model, we'll actually be getting data for this test column. And that was another example. And here we have a slide. In this specific client, we needed to do both of these techniques, okay? So we had to do this dynamic schema because fields were being added to the application, and then we needed to implement dynamic object level security because different users had access to their own fields. So if you combine both of these techniques together and you have an application like the one we've faced, this should be enough for you to perform this dynamic schema and dynamic object level security and manage some custom fields in your applications. Okay, so Diogo is just going to say some final remarks, and then we'll take some questions if you want.
Okay, now, as I said, just some final remarks. As you can see, we wrote everything in PowerShell, but of course you could have done this in other programming languages. For example, in Python, more specifically in Fabric notebooks. This is also a possibility, and we are also taking that into account. We also make a version working in Fabric notebooks in Python. We are also thinking on working, in this case, more towards PowerShell, working on a generic PowerShell module. So instead of having to go through all that PowerShell code you saw and having to change everything up, you would do, for example, a module where you just invoke a commandlet, pass the correct parameters, and it will get pretty much everything done for you, and you don't have to worry about all of that code, okay? And as of right now, our script is ready for JSON. So as of right now, our model beam in this case was in the JSON format. We also have Timdal coming soon. It's also in public preview, actually. And as of right now, it's working for format JSON, but it's also something we are taking into account to have it also working with Timdal, of course. So here you have our Linktree QR code. So here you'll have our session feedback. Please do scan this QR code and give us some feedback. It will be very helpful for us. You also have some prizes if you provide feedback to the session, so please do give us some feedback. You also have our GitHub repo link, so you can see all the PowerShell scripts we have shown you here. We also have DevScope's YouTube channel. We have a lot of videos there from YouTube, SQL Server, Databricks, and so on. So you can also take a look at those. And finally, we also have mine and José's LinkedIn, so you can connect with us, discuss some topics regarding object level security if you wish. And this is it for our session today. Thank you, guys.
Thank you.
So if anyone has any questions, we have a few minutes. I know this is it could be a bit too much. It's a bit much on the technical side, but the main thing that we want to show you is the possibilities that you have when you interact with a model B, which is the metadata from a Power BI with PowerShell, and just open a bunch of possibilities for you guys. Yes, please.
Stuff like this on your YouTube channel or examples on your GitHub?
We have this specific example. We do not have it. Yeah. So the question was if we have these examples on our YouTube channel. We don't have these specific examples. This is our company YouTube channel, but we'll possibly have some. We have other types of content, like from SQL to Databricks to a bunch of Power BI, a bunch of things in Azure. But if you want these examples, you can check our GitHub. We have there all the scripts. And we are hoping to launch a generic model to the community as well. If you want, you can follow us on LinkedIn, and when we have it ready, we'll be launching, and you can use it, hopefully. Any more questions? Yes, please.
What kind of use cases have you applied this for?
This specific one?
Yeah.
So it was basically this. Yeah. So what? Sorry. The question was, what use cases does this apply to? So basically, this was for this specific project that we've talked about. It was a project where we had a client that had a specific application, was a browser application that had a database. And this application, the users was an application for a bunch of users, and users were able to create custom fields for certain type of entities. For example, it was a human resources application, and they were like publishing new jobs and so on. And for example, if there was not a field available there, they had the opportunity to create it, the actual users. And we need to manage this type of situations where users are able to add new fields to an application that are then added to the database. And Power BI needs to manage this to have both schemas synchronized, right? The database one and Power BI. So that was the first application. And the second one was that the users could only see their own fields, right? So we needed to provide some security features so that, for example, if I created a field, Diogo doesn't have access to it. So we needed to provide this script, this dynamic object level security, where we would query a database schema and then check the actual permissions for different types of users, create roles for these specific users, and then provide the proper permissions that were on the actual database. Hope it answer your question. Any more questions? No? Okay. So I think we're done. Thank you guys again.
Thank you, guys.